Justin has 3 pairs of pants. For pants, he has black, brown, and blue. Looks like Let me try that again. Black, brown, and blue. I may not be able to do this on the iPad now that I think about it. We'll see. Might not have enough room. Shirts. He has a white one, a red one, a green one, and a purple one. Okay. Event C is defined as the outfits that have brown pants. Draw a tree diagram to show how many outfits Justin can make, then list the outcomes in Event C. So overall, what we're going to do is we're going to draw a tree diagram to describe how many outfits he can make overall. Then we're going to see how many outfits he'll have that have brown pants. You can probably figure it out. Has anybody already figured it out without drawing a tree diagram? How many different outfits with brown pants can he make, Chester?
4.
4. He's got 1 pair of brown pants and he's got 4 shirts, right? So it's going to be 4, but we're going to do this more just for the practice in drawing a tree diagram in case you ever have anything that's really complicated and you want to figure it out this way. So what we're going to do is we're going to start with pants because he's got less of those. Plus also we want to count the brown pants, so I kind of want to be able to look at part of my diagram when I'm done. So I could say he's got black pants, he's got brown pants, and he's got blue pants. So y'all draw this too on your paper as you go. So he could wear a white one with the black, or a red one with the black, or a green one with the black, or a purple one with the black. And then the same thing happens for the other 2, right? He could put those same shirts with a different color. And again, this isn't rocket science here. It's just, we're just trying to kind of see how we could draw a picture of what's going on. So for each one, put the color shirts with each pair of pants that there are. This is another way of showing our sample space, isn't it? Doesn't this show every option that he could actually dress? You know, he could wear black pants with white, or black with red, or black with green, or black with purple, and the same thing for the brown and the blue pants. Now, they said Event C is that he has the Event C is, let's see, defined as the outfits that have brown pants. So the outfits that have brown pants, that would be right here, right? So if we want to talk about how many that is, that's 4 outfits out of how many total? How many outfits were there total? 12. There were 3 pants, and each pair of pants had 4 shirts, so there would be 12. So that he has a third of his choices. If I reduce that fraction, 4 over 12, it would reduce to 1/3. A third of his choices involve brown pants, right? So we could talk about it that way. If I write out the event, and see, this is what I was getting at right here. Our sample space is everything. Our favorable outcomes are our event, or the things that we actually want to get out of the whole. And I think these 2 questions here were a little less clear.
Why can't it just be like event A?
I don't know. They just, I guess, probably to make you ask the question. You know, it's the only thing I can think of. Sometimes they just like to. I think they're trying to word things in very random ways, because when you get on achievement tests and SAT tests, sometimes they do that sort of thing just to mess with your head, you know, and they just don't want you to be thinking it has to be anything in particular. So if we're supposed to list the outcomes, we would do that in these set brackets. Our outcomes that we want that would be favorable would be brown with white. I'll just do what I saw some of you do. I'll put the shirt color in, they just use the first letter, brown with red. Oops, brown with red. How about brown? Brown with green. We'll just put G for green, and brown with purple. This would be the list of event C's that we want. We would call those our favorable outcomes. Our sample space is all 12 of these. And I'm glad they didn't ask us to write that out, because that would get old, wouldn't it? So this right up here, all of these, this tree diagram is a different way of writing our sample space. If we don't want to have to list it out with words like we did down here in event C, down here I listed it in words, didn't I? but there's so many there, we wouldn't want to write our sample space out in words. That'd get so old, we probably wouldn't be able to even tell what it meant when we looked at it. It'd be such a long list. But if we look at it this way, doesn't that kind of clear up what's going on in this problem? Could you represent, this is called a combination. Sometimes in probability, they call these things combinations. If I wanted to know how many choices he had, didn't he have 3 choices for the pants there and 4 choices for the shirts? And when we did the sample space, didn't we find out that if we multiply 3 times 4, we get 12? Isn't that the number that we saw we had when we drew out the sample space? Since there's no duplicate things in these 2 lists, this is how we can do this is how we can tell how many possibilities they are. I'm going to give you another problem and let you see if you can figure out how many choices there are without drawing the tree diagram. So this is just an extra problem here, okay? Does anybody need anything off this page before I get rid of it? Okay? Wait. And let's see, I don't know how many choices Subway has. How many meats do you think they have? How many? 5. Okay, let's say they have 5 meat. How many bread choices do you think they have?
10.
Yeah, they got a lot of different breads, don't they? How many veggie choices do you think they have?
At least 15.
Okay, we'll say 15. How many sauces, like mayonnaise or whatever kind of dressing, do you think they have? 7. So, now they probably, and cheese, can't forget cheese. How many cheese choices do you think they have? I heard a lot of 4, so I'll just put 4 down, okay? So now, how many, if this is what Subway offers, how can I know what the possibilities, how many different choices I could make when I go in there to order a sandwich? How many total possibilities are there given these numbers? And I know Subway actually has a commercial where they say, or at least one time they did, where they say there are blah, blah, blah choices, for sandwiches. Given what happened on that problem before where we had the different lists of things, pants and shirts, and we could multiply them and get the total, what do you think we could find the number of total choices we could make when we walk into Subway about different types of sandwiches we could walk out with? Given these numbers, what do you think I'm going to do with them to figure that out? Quinn?
So I think you can do, since there's 5 choices, like meat, bread, veggies, sauce, and then you can multiply that by
You're right.
1.
You could multiply all these Add
them all up, and then...
Well, when we did the shirts and the pants, did we add them up?
No.
No. What did we do with them? How did we get 12 when we went back and looked that there was 3 kinds of pants and 4 kinds of shirts? How did we get 12? We multiplied. Guess what? We can multiply here. Would you want to draw that out with a tree diagram? Oh, wouldn't it take you all day? I mean, no one wants to do that. So we could just multiply these. 5 times 10 would give me 50. Let me see, 50 times 15. I'm not good at going fast. That's 750, I think. Okay, so that's up to 750, and then we need to multiply 750. I'll multiply 7 times 4 is 28. So let's multiply 750 times 28. You could come up with how many different possibilities of sandwiches. That's 56 and 4 makes 60. And then 2 times 0 is 0, 2 times 5 is 10, 2 times 7 is 14 and 15. Let's see. So just based on the list that we know, there would be 21,000 different variety of a sandwich you could pick. Maybe you just want lettuce on your sandwich for the veggies, or maybe, you just want tomatoes or something. Or maybe you want both, right? There would be 21,000 different ways if you had these choices to make a different sandwich. And so you have lots of options at Subway, right? A lot of places like that.